Hello, this is Kamal with the Ilastik team, continuing the series on features. In this video, we'll cover edge features. You can see that I've again generated a simple dataset for demonstration purposes. Let's select a single edge feature and visualize it to see exactly what gets calculated. You'll notice that this feature group calculates three different features: Laplacian of Gaussian, gradient magnitude of Gaussian, and a difference of Gaussians. Let's start by looking at the gradient magnitude of Gaussian feature. As you can see, it detects edges and assigns them a high value, and assigns a low value to homogeneous regions in the data. It works by simply taking the Euclidean norm of the first derivative in each direction. Next, the Laplacian of Gaussian feature also does a good job of finding edges, but here it's taking the second derivative, which is why you'll see this characteristic double line along edges and intermediate values everywhere else. And finally, the difference of Gaussian's feature looks very similar to the Laplacian of Gaussian feature, and in fact it's really calculating an approximation of it. So, now you've seen what gets calculated for the edge features. Let's take a look at a data set in which calculating these edge features really makes a big difference in the prediction accuracy. The task here is to identify the boundaries between the circles and the background. This task is pretty difficult for a classifier that only has access to color information, because in some areas the background is white, but in other areas the background is black and the circles are white, and there's this gradient in the background from left to right. So let's try it first with color features and see what happens. You can see I've already made some labels and labeled a few pixels. Let's start live prediction and see the results. It actually doesn't do a terrible job, but you'll notice that it's picking up on the background as it goes from light to dark, and the boundaries between the background and the circles are very noisy. And if we try to smooth away that by adding some of the larger features in the color group, and again look at the results. So it did smooth away the problems in the background, but now we have very strange shapes for the boundaries, and again some noise in there, where it's not perfectly finding the boundary. But as you might expect, if we use both color and edge features together, we should get much better results. No problems with the background, and no problems with noise in the boundaries. So, in this video, you've seen what gets calculated for the edge features, and a simple example in which using these edge features makes a lot more sense than using color features. That's it for this video. Thanks for watching.